That's easier. So welcome everybody. I would just love to know why you're here at this session. Are you, what your interest is? Put it in the chat. Are you an educator? Are you a student? Are you just looking for a fun project to do? What brought you to this particular session so that I can frame my presentation a little bit? I do a lot of presentations for educators, but if you're not educators, then I'll keep that reference out of it. I do a lot of direct hands-on projects with students. So I just want to get some sense of who you are and why you're here, and then I can so put in the chat why you've joined this particular session. And that would just be helpful for me to know. And I know that we're also recording this, and so many people may watch it after the fact. I know that not everybody that people will see this who are not actually online with us today. So if you can at least put in the chat while you're here, and then I will get started. Okay, so let me go back to the first slide. So I'll start with an introduction about me. My name is Godwin Morris, and I run two programs in New York City. Both are physical locations. They're one block apart. One is a makerspace with laser cutters, 3D printers, and electronics, all the sort of hands-on making, and that is called Skill Mill NYC, and it's on the Upper West Side in Manhattan, a little bit south of Columbia University, if you happen to know where that is. And then I also run a STEM education center called Dazzling Discoveries, and it's in another building, but it is nearby. So I have these two spaces, and in those places, we run camps and after-school programs and a lot of professional development sessions. Now, obviously, we've been online a lot in the last 2 years, but we are definitely back in person. And I'm actually running a session for adults on April 2nd in the morning about how to make what we're calling a circuit city. So how to build a small model of a wired with lights and wiring, as if you were building the model of a city with the electrical circuits. So if you're interested in that, let me know. My email address is on this screen. So I've been teaching adults and I've been teaching kids for over 20 years. And during that time, I created a product called Dazzlinks, which is a cardboard engineering kit. And that is a product I designed. We manufacture it. I ship it from my location. We have complete control over it. It's not on Amazon. And then also I created a methodology called engineering with paper. And that's what we're going to talk about today. And that has been something I've been doing for 20 years. And we started to document it about 3 years ago. And then, of course, the pandemic hit, and it was perfect because it allowed kids to make things at home with the supplies they already had. You didn't need to get any fancy equipment to them. So I'm going to show you what that is and what kinds of things we make, and then we'll make a project together. So if you are actually going to participate with me, you want to get some paper. I think 3 sheets of paper would be good. It could be copy paper, could be scrap paper. We've even used newspaper. Not as great because it's a little more flimsy, but any kind of paper. Old manila folders are great. That's a little stiffer, but really any kind of 8.5 by 11. It doesn't even matter. The size is not really the issue. It's just to have some sheets of paper. And if you have any tape, masking tape or Scotch tape is best. That blue painter's tape is also good. I'm not a big fan of packing tape. It's a little hard to work with, but any kind of tape that works for you is okay with me. And then scissors, although the project we're doing today, you really won't need scissors for today's project, but some of the projects we do, you would need scissors. So make sure to get a couple pieces of paper while I'm going through this page. So this is an overview of some of the projects that we've created, and you can see it covers a wide range of science and engineering topics. And the objective is that you can teach many, particularly physics topics, using just paper, tape, and scissors. You don't have to have extensive equipment. Equipment is great, but sometimes it's really helpful to not have to put together all the equipment and just use some simple supplies to make some projects. One of the patterns of our projects is that we use the same shapes over and over. And you can see it a little bit here where this, in the simple machines in the upper left corner, is we're going to actually be making that catapult in a little while, but it's got a track piece. That same track piece is in several of our bundles. And that's the idea, that you can use the same shapes over and over in different ways, and to learn the basic shapes before you make any of the projects, and then use them in different ways. In the last couple of years, the New York Times ran articles about projects that could be made with newspaper, and they featured 4 of our projects. It was very exciting to be published in the New York Times, and this is one page showing all the projects that are in the New York Times, and you can find them by searching my name on the New York Times website. This is a picture montage of projects, kids doing the projects. The ones on the top were actually before the pandemic. They were still doing them, but now everybody's wearing masks. So these are unmasked children because it was before the pandemic. And then the ones on the bottom are Zoom pictures. Those are all kids doing things at home. So we were able to give directions and guide them, and they were able to make amazing things right in front of their computers for us. So the underlying concept of what we do is that there are lots of challenges, whether they're physics projects or any of those STEM challenges that you can find if you do a search on Pinterest or Instagram, or you just see things everywhere, particularly if you're an educator. And families too, there's just lots and lots and lots of challenges. And what we've learned over the years is that some kids just don't know how to get started. And the premise of our Engineering with Paper is to show them some basic techniques, again, these shapes that I mentioned earlier, and teach them those so that if you give them a challenge, like how to make a common one is a ramp or a roller coaster, and try to have the slowest, have your ball roll down the slowest of all the kids in the room who might be doing this, or obviously to make it go faster or whatever. Whatever these challenges are, some kids seem to know how to get started because they've had prior experience, but not everybody has. And we often see kids who are just sort of panicked because they just do not know how to get started. So we encourage what we call leveling the playing field, running through how to make these shapes with all the students, practice them with scrap paper so everyone knows how, and then move ahead from there. Okay. So now I'm going to show you what I mean. This is a picture of 2 of our very basic shapes. One is a cylinder, one is a track. The cylinder is literally a strip of paper, could be any size, could be the whole sheet of paper, it could be an inch of the paper, a strip of it, you roll it up into a cylinder. What can you do with a cylinder? Many, many, many things. And then the track is also a strip of paper. Again, the paper could be any size. I've done this with index cards, and I've done it with full sheets of paper. But the idea is that paper is very floppy. Here. So if you can see me in my little box here, the paper is very floppy. And when you fold up the edges, you stiffen it. And by stiffening it, you can then use it. And you can use it as a track. We use the track in our bridge project. We use it in many projects. So here's an example of our catapult. We do sell a lot of our instruction packets, but we also have several free instruction packets on the website, and the catapult is one of them, and probably one of them are most popular. And I'm going to go through the steps about how to make this in a few minutes. So I'm going to move past that for the moment. We'll come back to it. This is a basic ramp, and this is great for teaching angles. You can test the ramp, change the angles on the ramp. It's just a fun slide. We also make a lot of playgrounds. So this is a slide. And then this is our roller coaster project. So those 3 projects, the roller coaster, the ramp, and the catapult, all can be made with just those two basic shapes that I just showed you. They can all be made. You can see the cylinders are holding up the tracks, and the tracks are taped to the side of the cylinders in different ways. Now we have a roller coaster packet, and that shows you how to make more complicated roller coasters and how to make turns and add some extra features. But the basic concept, as you can see, is you just need these cylinders and the tracks, and you can make a roller coaster. And now I'm going to show you a few of our other projects. This is our balance beam, and this is actually a great math tie-in, because if you make those loops that you see hanging on the beam, again, that is a track, same shape. The loops are cylinders, but paper folded up, and the mass of the paper, if you make all the loops, each loop with the same size paper, then the mass is the same of each of your loops. You can do some math experiments with it, as well as general balance and learning about where the center of gravity is on this stick. This is all made with paper, tape, and scissors. Here's our parachute. Just see this, let's make a balance. There's the parachute. And these are all packets that would come with black and white line art instructions. This is from our wheel and axle packet. I have a few pictures from that packet. This is a vertical axle spinner. These are cylinders. Again, I showed you earlier, two shapes, tracks and cylinders. These are two cylinders, one wider, one a little more narrow. They fit inside each other. This is our vehicle from the same packet. Again, it's using cylinders in many places. We use some of our other shapes as well. And it works, really works. This is our horizontal axle project. This is a version of a Ferris wheel. Again, the cylinders are the core part of this. What you add to it, these happen to be our paper tray shape that we've added to this particular one. It's also used to hold the legs together, and we use this paper tray in some of the previous pictures as well. But again, it's just, the idea is basic shapes and attaching them in different ways. This is our creature packet. This is a maze. This we use a lot with coding classes, particularly beginners, because it's really helpful for the kids to make their own paper maze first before they start coding, particularly because mazes are such a common activity when you're learning to code, is to create a maze game. And so to make a paper one first is helpful. And it's really a lot of fun and really simple. And again, we have all these as downloadable packets. This is a puppet from our storytelling project. And I will show you later, we have an Instagram account, and that's a really great place to see all of these projects. The idea is you're very welcome to use our projects. If you can figure them out, understand them from just looking at the pictures, great. We created the step-by-step instruction pages so that it's easy to hand that out to students for them to follow along and see what to do. This is another one of our free downloadable projects. It's a city block. This is what we call our Be Anything hat. This is particularly good for younger grades. Some of the other projects, particularly the cylinder projects, those are definitely better for high school, middle school ages, but this one's really great for the younger grades. And you can use it for anything. It's strips of paper that make a basic hat, and then you add on to it. We do it a lot when we talk about animals and animal adaptations, and we have kids make their own animal head pieces. Sometimes they do it as an insect hat, and sometimes we just do it for fun. And this is, again, downloadable from our website. And then this is just the concept of using paper straws. I'm a huge fan of paper straws, of making them yourself. They're really easy to do. We roll them up. We have kids make them. The more you have, the better. It becomes a building material. This is actually really excellent for high school and college and adults, because you just are using these paper straws in unlimited ways. There's no right or wrong way to do this. We have a particular paper clip method, where you open up the paper clip in a way that allows it to connect to the tube, allows you to connect the tubes together, or you can use paper brackets, but I highly recommend rolling paper into straws. You roll it around a pencil or a dowel and make many of them and then build. Okay, so now I'm going to show you how to make one of the projects. So again, if you are following along and you came in a little late, you want to get some paper and some tape and some scissors. Copy paper is great. Any kind of paper works, any size paper works. You can do it with index cards, you can do it with copy paper. And any kind of tape, preferably Scotch tape or masking tape. And scissors obviously are pretty easy to have. You can even rip the paper if you don't have scissors. So I don't think anybody's participating. I'm just going to keep going. I think many of you will watch this as a recording. So. All right, so again, back to that basic concept that I talked about earlier, simple shapes. So this catapult project and the target are made with two shapes, cylinders and tracks. The backboard is also a track piece. It's just a wider track piece. And here is the catapult, and I'm going to go through the step-by-step so you can see how this works. Okay, so when we do this with students, we do what we call prepping the tape. And as educators, particularly with younger students, you want to pre-rip the tape. If you're doing this at home, you want to pre-rip the tape, because as you're rolling the paper, you need both hands. And so you don't have a third hand to then rip the piece of tape that you're going to need. So if you pre-rip it, put it on something that's ceramic or plastic, something the tape won't easily stick to, then you can just pop it off and use it as you need it. With older students, we give them a strip of tape and scissors, and they cut it up. They cut up their own small pieces in advance. Okay, so I'm going to try to play this video, and you'll tell me if you can hear this. And if not, I will talk over it, but I'm going to see if you can hear it. It's going to be a step-by-step instruction about how to make the catapult. So just give me a thumbs up from the hosts. Did you hear that?
Oh, we don't hear anything.
You don't hear anything. Okay. Where is the, maybe on the share? Do you know where that
setting that you can share your
my sound?
Yeah, there should be an option for you. I don't see an option for me to allow that.
Oh, share sound. There it is. Okay. Okay. So let's try this.
So we're going to make a ball out of paper.
We can hear that.
And we are going to make.
You can? Yes?
Yes, so we can hear that.
These three parts. So this is called the fulcrum. This is the catapult arm. And this is the cup to hold the ball. The first part we're going to make is the fulcrum. So that's this tube. And we start by folding the paper in half to make it more layers, which will make it stronger. So we're going to fold the paper, the short edge to the short edge, folding in half. So we're lining up the corners, folding in half. We want this to be a tube, so we're going to roll it up. But before we roll, we're going to take our tape and place it along the short edge up here. We're going to flip it over so that the sticky side of the tape is facing up, so that when we roll to make our fulcrum, we will end at the tape and it will close itself. So roll up your folded sheet. Try to roll tightly. And as we get to the tape, just keep going so that the tape holds it in place. And if you need to, you can add another piece on these ends if it feels like your piece of tape isn't holding it in place. So that's our fulcrum. Now we're going to make the catapult arm. And we take a new piece of paper. And again, we're going to start by folding this piece in half, the short side to the short side, to give it more layers and make it sturdier. So I've lined up the corners, pressing my fold down, and there we have half sheet of paper. We're going to fold it again, going the same direction. So this piece will be our catapult arm. As you can see right now, it's still pretty floppy. So here's a trick. If you fold the sides up to make walls, do that on both sides. And the more you fold in, the taller the walls will be. You wave that around, you can see it's a lot more rigid. So just by folding these sides up, you've made the paper more rigid and stronger and ready to become the arm of our catapult. We're now going to attach the fulcrum to the catapult arm. So again, just as we did when we rolled the tube, we put our tape before we rolled. So in this case, we're going to place our tape before we put the fulcrum onto the catapult arm. So I'm placing the tape kind of like arms, and I'm going to attach it around the middle of the catapult arm. So pressing down, really squishing the tape in, and I think I need a little more tape just to be sure. So I'm going to take another piece of tape. There we go. So we flip it over. We are ready to test our catapult. So from that third sheet of paper, just cut a section. We're going to rip this up and crumple it into paper balls to launch. Now we're going to test our catapult. So we're going to place the ball on the end of the catapult arm that's lowered and gently but quickly hit the other end. So you may notice that the paper ball is rolling off the back sometimes. It's going straight up sometimes rather than launching outward. So to adjust that, I'm going to add this loop or cup to hold the paper ball and help angle it to launch out rather than straight up. We can do that by just cutting a strip off of our catapult arm. It doesn't need to be this long. So I'm just going to cut the edge off at about an inch. It can be a little less, a little more. And I'm going to use this piece, open it up just halfway so it's still 2 layers, and turn this into a loop that will fit between the walls of the catapult arm. So I have my tape ready. I'm going to place the tape first, and I'm going to set it into the catapult arm and make a loop. And then I can tape that to the walls of the catapult on both sides. With the remaining paper that you use to cut a strip and then rip up and crumple to make the paper balls, we are going to make some targets. So cut some strips. The deeper the strip, the taller the target will be. So it's up to you how wide. I'm going to make a short one and some taller ones. So we're going to roll this into a cylinder, and that will become our target. But before we roll it, we're going to place our tape along the short edge with the sticky side up, so that when we roll that up, the tape is already there to close the cylinder. It's much easier than having to grab a new piece of tape as we're trying to hold our project in place. So there is our cylinder target. To help the ball go into the target, I'm going to attach a backboard. So I'm going to take a section of the paper and I'm going to cut a smaller rectangle. So this piece can be attached to the back of the target. But just as we folded the walls for the catapult arm and we noticed that it made the paper sturdier, we're going to do the same thing with this piece so that it's not so floppy. We're going to fold the sides in to make walls so that it will stand upright and be a more sturdy backboard for the target. I'm going to put my tape on. And I'm taping it from the back and the front. And you can make targets and backboards of all sizes. So there we go. Now I have a backboard. Visit our website, engineeringwithpaper.com, for this catapult project, which is a free download, along with a whole bunch of other great projects that you can build with just paper, tape, and scissors. Follow us on social media. Contact us at info@dazzlingdiscoveries.com, and keep in touch and have fun building.
Okay.
Today we are
Oops,
going to be
oops.
making a catapult.
So I hope that some of you tried it. Oh, good. Thank you, Kai, for making that. It's fun. I saw you smiling, so I knew you were playing with it.
It's kind of easy to follow, even along the video. Thank you for showing that. It's working. Yeah, that loop in the track really works.
Yeah, the loop in the track makes, yeah, it's so interesting. It makes the difference because it keeps the ball in place a little bit longer so that the angle of the track changes. It's actually, that's what I mean. So these projects, I do this with kindergartners and I do it with high school seniors. And so obviously with the kindergartner, they're going to play and try to get it in the track and just kind of see what happens. But you can actually do measurements with it with older students. So these projects really cover quite an age range. And then I love doing them with adults because they're just fun to make. So did anybody else make one? Anybody else want to turn on a screen or see? Okay, so this page is a little bit of an example. So in the packets, they're all black and white line art and everything's step by step. Everything is documented. It's very clear. It's really great. We use them in our own classes. We print out the pages. We put them in pocket protectors, those clear sheet protectors. And then you can give them to students and they just follow along about how to make the basic shapes and then how to assemble some of the projects. It's really meant for everybody to be able to use it. let's see. Oh, so then one of, oops, before I go now, I've shown that. Wait, 1, 2. Okay. So then with this project, particularly because we teach people how to make it exactly this way, we then add a challenge of how would you get the ball to come back to you? And there are actually a lot of ways. I've had people attach a sort of thin strip of paper as a string to the ball. I've had people make tunnels. There's a lot of ideas if you think about it for yourself. What would you do to make that ball come back? This picture is just a really simple version where we put a track on the target so that it can either fall in around the track or it's actually hitting that backboard and coming back down directly on the track. This is just one way to do it. It's definitely a good challenge. Again, for older students, it's better than for the younger ones. So you can see, and we're always so pleased when we're doing these videos and the balls actually go into the target or into the track. You know, that this one worked. So doesn't always work, but works enough that we were able to capture it. This page gives you a range of the kinds of content areas you can use when using engineering with paper projects. It's pretty unlimited. Again, we work with schools, and so these relate frequently to curricula. Anything about energy, about transfer of energy, about force and motion. Clearly, many of our projects work with that. We also have a habitat series and cityscape. We just released a bridge project about how to make the basic bridge, which is actually made with that same track piece and cylinders to support it. But then we have all kinds of movable, what we call movable bridges, or moving bridges where the parts move. So if you have making a bridge that can open up, lift up, you know, if it's over a river and a boat has to go through, or those kinds of bridges. So the packet has everything from this very beginner track on cylinders experiment all the way up to making, lifting and moving movable bridges. Simple machines and playground design, very popular. And then creatures and animals, I showed you a little bit of that. Architecture, we do a mission to Mars. If you're going to go to Mars, what do you need when you get there? Well, obviously you have to build everything. And so if you were just bringing sheets of paper or sheets of metal or whatever material you're going to work with, you can bring them in flat sheets and then build it when you get there. That's the idea behind that lesson plan. Force of motion. If anybody else has ideas from what you've seen, we have the whole aerodynamics. We have a whole bundle of projects made just for dropping and watching what happens. How items spin, items fall, the parachute. This is what the packets look like. The pages are all, as I said, black and white line art. The tops are color-coded. We have what we call technique pages, which are the pages that show you just how to make the shapes. Does not show you how to make the projects. It shows you how to make the shapes. And then we have additional pages that show you how to make the project, how to put the shapes together. You can use those or not. We have a lot of people who just get the technique pages from us. It's actually what we do in our classes. We teach the kids how to make the shapes, and then we give them challenges. So now when you see this picture, it should make a little more sense. You can again see that we have a lot of the same shapes, rectangular prisms, paper tray. Our paper tray is used in almost everything because we use it as a base. So it's the base of the habitat. It's the base of it, the home on the upper row. It's both the ceiling and the floor. It's the base for the wheel and axle. And the nice thing about that shape, it's a paper tray. Essentially, you cut these little flaps on the sides. You can make it in a full size and use it as a base, and you can make it in a couple of inches and use it as a bed or a refrigerator or a bookcase or whatever. It has a lot of use. This is an example of, again, our roller coaster with a rectangular prism instead of the round cylinders, and you can see some of the curved tracks. And this is also showing our DAS Links, which is our cardboard engineering kit that you can also use to make a a roller coaster. That's probably one of the most popular projects because it's just really fun to try to figure out how to make it. And again, this can be done with younger kids where they just do a couple of turns. We've done it with adults. We have to make multiple turns, wrapping it around, and it can go inside and in between. It can be bigger. You can have more posts. When we teach roller coaster, the most important concept is what happens with the roller coasters is everybody thinks about the track, and people don't always think about the supports, but it's really the supports that matter because that's what holds up your track, and you need to have enough of them, and they have to be sturdy and in the right places so that you can then add the track. So that's the kind of approach we try to use in our lessons, is to think of more of the whole picture of what's happening, not just the fun part. This is just more of our dazzlings. This is our cardboard engineering. And again, you can make multiple projects with them. We have two kinds of dazzlings. One is a beam shape, and that's on the left. And the one on the right is a flat, mostly flat shape. So we have one box shape, but mostly it's flat shapes. And they all have holes in it, and you can attach them with those metal fasteners, those brass fasteners, and the shapes go together with dowels. So in a classroom, they're great because you just pull it at the end of this period, you pull the dowels out, the whole thing comes apart, and then you're ready for the next group of kids. This is just fun. I invented this. We designed it. This is a contraption project we designed with it. It's meant to be very open-ended and flexible. And then this is me, and then you saw Paula in the video. My email address is on this screen. And then we have our Instagram. I highly recommend looking at Instagram. You obviously don't have to have an Instagram account to see this screen or see our Instagram pages. It's really our photo album. We show all of the projects in our Engineering with Paper and our Dazzling Discoveries Instagram accounts, and it's just great to see the projects. We have many projects. A lot of them are made with paper. Some of them are made with other supplies. We also have a Dazzlinks Instagram account. And then to reach me, in addition to the email, is Twitter. It's my Twitter account with my name. And so that's always a good way to communicate too. And then our Facebook group, where we get to communicate with you and share projects and ideas. So we have about 10 minutes more. So I'll stop sharing for a minute just to see, is there anyone want to turn on a screen or ask any questions or say anything? I see lots of names on here, and it's always hard to know whether anybody's actually watching at the moment or looking at it after the fact. So
thanks, Erin. So I will open the questions for questions. So anybody has a question, you can. Yeah, I see Daniel has a hands up. You can just unmute yourself and ask a question.
I was watching. Thank you very much. I enjoyed it.
Thank you for telling me. I appreciate it.
I used to be a package designer long ago, with cardboard and stuff. I've done a lot of other things too. I won't tell you about.
Well, just tell us about the package design. Just really simple, how does one approach package design when you have that full sheet of cardboard? How do you know how to?
Well, I was working in a corrugated box company before I went into the Army, and as an apprentice sample maker, you have to make samples of all the things that the salesmen take out to sell. And so you're folding up corrugated cardboard, mostly making basic rectangles, one size or another.
And then it has to be scored, and it has to
it has to be scored. And then they also made packages out of regular cardboard for things like donuts and whatever.
Yes, and pizza box cardboard.
They had fascinating machines called printer slotters, which would both slot, cut, print the form all at the same time. And these things would do incredible rhythms They would go, chucking it, chucking it, chucking it, chucking it, and this stuff would come off it, one slice, one box at a time. And then go down a long assembly line and something would fold it up with fingers, stuff, and it was fun. It didn't
It
last
was.
very long because I got drafted.
Okay, but still, that's the idea. And actually, we use a die for our dazzlings,
Yeah.
and so I've seen that whole factory.
I mean, all of these things are die cut, even the big
Yes.
corrugated boxes.
Right. But that's why we switched to paper, was that a lot of schools use cardboard. There's a lot on cardboard construction. You can see that. I created dazzlings out of cardboard, but we realized that to make it really easy and quick and accessible, that paper was just better for teachers, particularly, or kids at home. It's just quicker. You have it right there. You don't have cardboard's just a little harder to attach.
Well, cardboard it's harder to cut.
Right. Exactly. So
So
that's why we created this whole paper thing. Go ahead, Kai.
I was going to say, we still
thank you.
have
It was great fun.
questions. So Daniel, do you want to ask a question yourself?
I do. Ms. Morris, question for you. On a higher end educational platform, for example, beginning engineering students, mechanical engineering, where do you have any designs or plans or challenges that engineering freshmen or sophomores could use, for example, to do a bridge, but to hold up with a certain amount of paper, hold up a brick, for example?
Yeah, so we provide the fundamentals, and then you provide the challenges, whatever works for you. One of the things that I like to see done is the paper straws, and have them roll them so they're all the same around pencils. It's pretty simple. We always put the tape on first, because then when you're rolling, you roll right over the tape and it's easier. But make a bunch of paper straws and then give them some challenges of things to build. And definitely you could do it where you have to be able to hang a weight from it or put a weight on it, but you have to build a structure with just paper straws. And then you have to have some way to connect it. Our paper straws packet has all this in it. It's only a couple of dollars, a few dollars. And you can use it for a whole, all of your students. You don't need to buy one for each student. You buy one packet and use it for everybody. But we just show you different ways of connecting them. That's helpful. But then, yes, be great to use it for. I'd love to see pictures of that.
Great. Thank you.
So.
We have another question from Fred. Hi, Fred.
Yeah. Hi. Very, very fascinating. Very interesting. I had a very, very dear friend who worked with origami for many, many years and wrote books. And back in the days when they did vinyl, made a record on origami. Had another friend who wrote a book on the toy book, on a toy book based upon very simple things like toothpicks and peas on engineering principles. My question to you, however, is you mentioned that you integrate some of your projects with coding. I'm currently working with an 11-year-old who is very much interested in coding. And, I'd like to have him have more of a foundation in the real world. I mean, he's very artistic, has a good, sharp eye. How would your projects integrate with coding?
Well, the maze is the most common one that we use, which is a downloadable package. You make a maze out of paper, a physical maze that you either tilt or put it on levers if you wanted to do that. But the idea is you're making this maze, because mazes are often the activity that coding beginners do. They make maze games. So
Right.
we make physical. We have kids make the physical paper maze first, and then so that, because it helps with the left and right and the tilting and all that. So that's one. And then a sort of an extension of that is that you can, if you're more sort of when you get more advanced, or if you're working with physical computing with either Arduino or microbits or any of those devices, you can take the same maze, or actually almost any of our projects, and add electronics to it so that you can code it to tilt based on the coding. Am I making sense? So you'd wind up making it into a codable game for left, right, forward, back that you can write the coding lines for, and then the building physically a maze and then a device that has the wires and the servo motors under it that would respond.
Okay,
So-
we're at a much lower level using Scratch. He has worked with mazes and self-navigating an object straight and right and left, but also we've also worked with self-driving cars, so that they hit a wall or they sense a wall that they'll turn. I'm just thinking how a paper project or cardboard project might enhance that.
Well, one of the nice things about Scratch particularly is that you can take pictures or even little videos and embed them in your Scratch projects. So you could build a roller coaster or a maze or any of the projects and then build it into, and then try to replicate it with code, the same images or the same actions. And you can use the pictures in your actual finished program.
Okay. Didn't know that. You can integrate video into Scratch. Okay.
You can definitely integrate photos. I don't want to promise you that you can integrate little videos. You probably can integrate GIFs, but you could definitely do it with photos. And then you could do, have you ever done a flip book, digital flip book? So if you do multiple, you take photos in a sequence and then, run them at a certain speed. So you could do that. You could code that in Scratch. So you could build physical things. You could take pictures of him building the physical thing, each of the steps, and then he could create a Scratch program of how did I make this?
Oh, okay. All right.
So, but you definitely can embed your own pictures into Scratch.
Yeah, it's definitely important to connect to the physical world. Programming can be, I've been in the computer field for a long time. It can be a lonely occupation, but connecting it to the real world, I think, is very important.
I do a lot of this in my STEM education program. So we do that. Thank you. Thanks for those questions.
Thank you. Does anybody else have questions? Please feel free to.
Oh, I'm sorry. I just want to mention one thing. I actually looked into adding video files into Scratch. It is possible to add GIF files into your Scratch program. So yeah.
Thanks. That's what I thought. That's what I said. The GIF files can go in, but maybe not an actual video clip.
Yeah.
Thank you. Thanks for checking that.
Yeah, no problem.
I hadn't never tried to do the videos, but I have done the photos and the GIFs. So. Oh, great. All right. Well, I think we're almost set.
Yes,
we're at 3.
We're some time. Yeah. Then I guess, thank you so much again for the presentation. It's very interesting. I'm
just going to share. Let me just, where'd it go? I'll just share that contact screen again, or this one.
Sure, that would be helpful.
To have that if anybody needs that. Go ahead. You want to close it up?
No, it's okay. You can keep this open, and anybody who can write down the context and contact you later. All right. So, okay.